Okay, boys and girls, we will continue our lesson. Lesson number 25, thermal expansion. Okay, actually that day we already finished talking about the theory. So today we'll continue do the past year questions. Okay. But before we go to the past year questions, we roughly have a look about thermal expansions, the important concept part. Okay. So thermal expansions is because we heat it and then the volume increase. Here, I want to emphasize your explanation cannot mentioning particle expand. This is a very wrong concept. Okay, if you look at this diagram, you will find out that the particle size still remain the same. You see, the particle size still the same. It's just take up a larger space only. Okay, the volume increase, take up more space. But you cannot say particle expand. No. Okay, you can say this metal volume increase. Yes. Okay. Then after that, for the thermal expansions, in the past year, if they like to asking you, test on you the idea, most of the time is about the mass and density. So this part you have to know. When you expand, heat it expand meaning that the volume increase. So how you relate with the density? You need to write down the formula. Density equals to mass divided by volume. So when the volume here increase, your mathematics, a value divided by a larger value, you will get a small value. For example, 1 divided by 1000. So your value will become very small compared to 1 divided by 1. Okay, if your volume increase, so this part divided by a big value, so your density will decrease. Okay, how about the mass? Don't forget, when we learn about force and motions, we also got mentioned mass is amount of metal. So it won't be changed all the time. It won't be changed no matter on the earth or on the moon or whatever where you move. Mass is the same. Okay, mass is the same. So these two concepts that you have to know lah. Okay, then we try with the past year questions. So we go to the page number 11. Okay, that day we stop at here. Haven't continued with the past year questions. Okay, boys and girls, you read it. Okay, 10 second, 20 second, 20 second. Can you try tell me your answer? Type your answer in the chat box to the Newton Scholar. Then I will check your answer. Okay, right now, engineer design is in the cold environment. Okay, so what happens if the weather become hot? Angeline, yes. Sure, we didn't learn this topic at all yet. What do you mean? Last week we stopped at here. 10.1. What Shu-En say? 10.1 thermal expansion. Last week we no class. We have class, dear. In the group I got mentioned we have class. Last week got class, dear. Replacement class. I did mention in the group. Crystal correct. Emily correct. Zihua correct. Okay, dear. This one is during the cold day. Okay. Then if you are hot day, it will expand. When it expand, it even become more longer. Okay, so the problem is hot there is expand. Okay, so only B or D. So answer here, answer this, D. Okay, answer should be donkey. So when you design during the cold day, actually you can design like this, slightly enough lah, dear, slightly enough. So when hot day, it will become longer. So it expand is in all the dimension. Expand is in all dimension. It's not only certain dimension, no. Okay, overall. Okay. So if this is the part like this, okay, it expand, including the area also increase, then longer, it will become longer. So in all the dimension, it will increase, expand it. Okay. So the correct way during the cold day, so actually you should be slightly enough lah, slightly enough. So when the hot day, so it will be slightly loose, but okay, it's fine. Okay. So number two. Okay, can you try the type your answer? Okay. I share the video recording for the last week first. Last week, after conversion is already like midnight. That's why I didn't send out. Then after that, I forget already. With me for sure, you answer the questions for 2 and 3 and 4. Okay. Whilst I trying to send the video recording, last week video recording to the group, you try the question 2, 3, 4, dear. It's too hang. Okay, let me check Angeline answer. Correct. Shu En, Crystal, correct. Okay, answer for this question, there is a gap. Why there is a gap? Okay, answer at here, our answer should be A. We allow it to expand. We need to allow it to expand. Okay, so when it expand, it still got space. So as I told you, your house, if the tiles break, it's because the temperature change, like they got difference in temperature, so they expand and contract too fast. So at the end, when they expand, also there is no space for it to expand. So the tiles, house tile, it will be break. So if really break, you need to spend like more than 10,000 to repair it. Okay, to replace a new one. Okay, number three. Number three. Try and then tell me your answer. Angeline, correct. Then number four, no. Angeline, number four, no. Zihua, no lah, not for one tile. Because if you want to change, you have to change the whole part. Cannot be only one tile. Whole part. Okay. Zihua, number four, wrong. Emily, correct. Okay, number three, answer should be A. The distance between the two electricity pylons is 60 meter. Fit a cable of length 62 meter. Okay, why does the engineer choose a cable that is longer than the distance between? Okay, we allow contraction. So we will design slightly longer during the hot day, slightly longer. We need to do so? Why we need to design 62? It's because that is the part. If during the cold day, it will contract. When it contract, we allow it to contract without bending the poles, without bending the pylons. Okay, so this is the reason why we need to slightly longer. Answer would be A lah, so should be no problems lah. Okay. So next, we go to question number 4. Question number 4. No. Angeline, no. Zihua, no. Okay, let us have a look. Okay, number 4. Can you guys try? The solid line actually is the coolest part of the night. How about hottest part of the day? Which dotted line actually is the correct part? Try. Emily, no. Kristen, no. So far nobody answer correctly. Emily, no. Try to think. This one is during the coldest part, okay? Coldest part of the night. How about hottest part? If hottest part, actually it will be expand. So you imagine, this one is imagine starting like this. If they expand, where it go? Answer, answer, let me give you the answer. Let me have a look. Crystal, no. Zihua, yes. My dear new friends, I don't know how to pronounce your name. No. Okay, answer for this question, actually, Teresa, correct. Teresa, correct. Answer is A, dear. You already starting with this. Impossible you expand and then you become B, C, or D, because from this part, it will continue bend forward, bend upward, longer, become further longer. Okay, should be A. Shireen, okay. Let me record down your name. Okay, dear, did you get the idea? This one, like this, okay? Then when it become hotter, it will become expand. So you already like this. So you expand even more. So it should be go up, continue going up, okay? So here, answer should be A. Okay, dear, can you try with question number 5 before we discuss? Question number 5, 5A, B, and C. I want to share out the video recording. Okay, let me have a look about Zihua. Zihua, where's your answer? Angeline. Angeline say, where is the new position of your pointer? The pointer should be goes to the, what do you guys think? The answer should be goes to the left. So correct. Okay, why? There you look at here. This one is a fix already. So when it expand, it cannot expand to this part. So it can only goes to this part. It become longer, and then some more, can you see that here they still have some gap? Why? Because as I told you just now, they expand actually is all dimension, so they're not only in terms of this part, they will also here increasing, okay, slightly increasing the volume. Okay, so adhere to the left, Sherin, yes, correct. So dear adhere, you should draw your pointer to the left is because this length become longer, so it will push the roller, push this roller turn in this way. Okay, this one goes to this side, so the roller will turn. When the roller turn anti-clockwise, then of course, the pointer will be point like this. Okay? So your right hand side is already fixed. When it expand, they only can expand to the left, towards to the left, move to the left, okay? So when the rod move to the left, the roller will turn anti-clockwise. So at the end, the pointer will turn to the left. Okay, this one, the properties, this one just now I did mention already. Do you able to answer it correctly? Before we do the past year question, we already mentioned, tell you the This part, tell you about this part. How the density will goes, how the mass going, what happened to the volume. Okay, do you able to identify, do you able to answer this? Okay, let me check Crystal. Crystal said volume increase. Yes, volume will increase because we hit it. Keyword edge here is hit. Once we hit, volume will increase. Therefore, expansion happen. Okay, mass will stay the same. Very good. Density will decrease. Density is mass divided by volume. So volume increase, density decrease. Correct. 3 marks here. So that's why I told you this is the quite important concept lah. They will ask. Okay. 直话 correct. Right dear, disadvantage of thermal expansion. Okay, thermal expansion sometimes is good, but sometimes not good, not a good idea. We're having the thermal expansion, but we cannot avoid. Therefore, we forced to design so that we allow the expansion to happen. Okay, sometimes expansion is not good, but we forced to accept, no choice. Okay, it's naturally happen. So we have to design, for example, the bridge, we have to design the gap for it to expand. Okay, but of course, sometimes application we need the expansion. For example, thermometer. Okay, the thermometer, how come we can detect the temperature change? Okay, when temperature surrounding increase, thermometer will showing a greater reading. It's because inside the mercury happening expansion. Okay, the volume of the mercury increase. Therefore, it rises to a higher temperature. Okay, here talking about this advantage, that means that in our application of our life here, we cannot avoid. Okay, we cannot avoid, but we have to accept it. For example, the just now the exercise here. Okay, this part. You see, the telephone cable, electric cable, they will go down, okay, lower. So at here, we can write at here, what is the disadvantage? Example. So at here, we can say that the electric cables lower to ground. Okay, it will become longer and maybe touch to the ground. So how should we do? The designer, the engineer, they have to think, make it shorter during the summer, but still need to longer a little bit so that at the end at cold day they will be able to contract, we allowed to contract without bending the pylon. Okay, so this is the answer. Okay, we goes to your page number 13. Okay, we goes to your page number 13. Okay, this one, metal tire for a wooden wheel is made from an iron ring. Okay, so at here this one is iron ring. Okay, this inside is wooden wheel. Okay, the iron ring is made slightly too small to fit. This iron ring outside, we're going to fit inside the wooden wheel, but it designed slightly smaller. For example, from here to here, actually is 10 cm diameter, 10 cm radius. Then at the end, from here to here, is the ring, iron ring, maybe make 9.8 cm radius. It's slightly smaller. How can we fit it in? It's slightly smaller. How can you fit the ring in? Okay, into the wooden wheel. So what should we do? You see, explain why hitting the iron ring can help to fit. Why? So this part is slightly larger, then this part is slightly smaller than it. Impossible we can fit it in. Then what should we do? What should we do? Why we need to hit it? Okay, Crystal, let me have a look. Okay, we hit it is because we want it to be expand. Okay, yes, correct. So expansion, we want expansion happen. We want the ring gets bigger. When the ring get bigger, then we can fit it in. Okay, we can fit it in. It will expand, 子画 correct. Teresa, iron ring can expand and make it bigger in all area and will be able to fit on. Yes, correct. Okay. So at here, we want to make it bigger so that we can fit it in, okay? Then explain your answer in terms of the particle in the iron ring. Okay, so what happened to the particle in the iron ring? So at here, again, do not tell me that particle expand. This is a very wrong concept. Particle doesn't expand, okay? Vibrate more, yes, correct, vibrate faster. So at here, we say particles have more energy. Okay, or we say vibrate faster. Okay. We cannot say move faster because iron ring is a metal, it's a solid. So the keyword how we describe it is called vibrate. Instead of we say that move, cannot say move. Move is for the liquid and gas. Okay. Then the space particle move apart between each others, move apart. Or we say particle move apart, yeah, between particle. Or we say the space between particle increase, move apart each others. Okay, like this. Do not say particle expand. Okay, do not say particle expand. Move apart from each others. Move apart from each others. That means that here, they get a bigger space. Okay, or we say bigger space. Larger space. Larger space between particle. Like this. Larger space. But the size of the particle doesn't change. Let me have a look. Zihua. Kinetic energy between them increases. Vibrate faster. Yes, correct. Here, energy means kinetic energy lah. They accept the heat what? Okay, so they increase the energy. And at here, the energy means the kinetic energy. Okay, explain what will happen to the iron ring after it has been fit on the wheel and left to cool. After cool down, what happened to the iron ring? Okay, Teresa, it will contract dear, and fit evenly on the wheel. Yes, contract is the keyword. Only one mark, so we expect to see your keyword contract. It gets smaller. Okay, smaller also can. Zihua contract, yes. Bora contract, yes, correct. After contract, you will what happened? Next question is asking you what happened to the joint or in the wooden wheel after fitting the iron ring. Okay, when it contract at here, what happened to this joint? This is the joint part. Okay, this is the joint part. What happened to the joint? Any idea? When it contract, what happened to the joint? Any of you? Zihua. It break. We design this and at the end we want to break our things. No. Okay, when it contract, this part contract, so it will push the joint together, closer together. No break. Okay, we will design exactly like not breaking our apparatus, not breaking our things. Okay, so at here the joints actually will push together. Push together. Okay, except that compress, tight together. Okay, all this answer okay. It will bend, no, slightly only. It's slightly smaller. So slightly smaller, and then when it contract, it will push like this, push it in. So all these part they will closer to each others. Whatever the design by the engineer actually is not want to spoil the things. We're trying to make the things perfect and then good. Okay, so next, number 7. This one okay. Number 7. Most substance expand when they are heated. Step 1 or example where such expansion is useful. Just now I told you, thermometer. Thermometer is a useful application. Thermometer. Okay. Then fitting the steel tire. Fitting of this actually is useful. What? Okay. Fitting steel tires. Okay. One example where such expansion is not good, but we have to be allowed. Okay, it's not what we want, but no choice. We have to allow it, and then we have to design to allow the expansion. So this one is same as just now, or we can say that the expansion gaps in bridge. We have to allow it happen. Okay. Therefore, wire also yes. Okay, wire also. So the electric wire, just now electric wire, the telephone cables, all these is not we want, but we have to allow it happen. Therefore, in the design part, we have to design to allow this expansion or contractions to be happen. Okay, this part is about the thermal expansions. So this part, if you're using some logic thinkings, you still can understand what we are going on. So, okay, about the expansion part. Then next lesson, lesson number 26. This one is very important. Okay, specific heat capacity is very important. So please pay attention. Here, this part is already settled. Then we go to lesson number 26. This is the very important topic. Then it's something new for you. Okay, is that clear? Can we go to lesson number 26? And there is a reaction button, press it so that I know that everybody get ready. So we go to the lesson number 26. Okay, Crystal, Serene. Okay, idea here. Specific heat capacity. Okay, what is specific heat capacity? Specific meanings that at here meanings 1 kg. We specific the mass, okay? Heat is the thermal lah. Capacity is the amount of energy, thermal energy we need, okay? So at here, if you want to heat the aluminium and you want to heat the water, do you think that they will be the same? My answer is, of course, they are not the same. Okay, in order to increase 1 kg of water by 1 degree Celsius, we need 4,200 joule of energy. We need to supply 4,200 joule. 1 kg of water only can increase their temperature by 1 degree Celsius. But for aluminium, we only need 900 joule. Then we can heat the 1 kg aluminium, increase temperature by 1 degree Celsius. So at here, which one will be heat up faster? Which one easily heat up? Can any of you tell me? Aluminium or water, which one can heat up faster? Aluminium. Zihua say aluminium. Is it true? Yes. Every 900 joule, this one increase 1 degree Celsius. Another 900 joule, already 1,800, it increase another 1 degree Celsius. Then this one, another 900 joule, it become 2,700. So it increase again. But here, 2,700 joule we already supply. The water even haven't increased 1 degree Celsius yet. So can you see that when aluminium already increased 3 degrees Celsius, water even haven't increased 1 degree Celsius because water need 4,200 joule. So that means that aluminium heat up faster. So their specific heat capacity can tell us what is the specific heat capacity for aluminium, which is 900 joule per kg per degree Celsius. So at here, specific heat capacity is 900 joule per 1 kg per 1 degree Celsius. So every 1 kg of the aluminium, we want to increase 1 degree Celsius. Amount of heat that we need is 900 joule. This is the meaning of specific heat capacity. So if your C value is low, can you see that aluminium C value is low? It will heat up faster. Okay? So this one, C value can tell us what information can tell us. It can tell us that whether this material can heat up fast or slow. Okay, because fast is because only small amount of heat energy is needed. It already can increase the temperature. Okay, so the definition is very important at here. The specific heat capacity is amount of thermal energy required to raise the temperature of 1 kg substance by 1 degree Celsius. So these three have to mention because C is the heat energy 1 kg 1 degree Celsius. Amount of thermal energy required to increase the temperature of 1 kg substance by 1 degree Celsius. These three physical quantity have to mention. Okay, then we look at here, this one, copper block, aluminium, and water. So this is their specific heat capacity. For water is 4,200. For the copper is only need 390 joule per kg per degree Celsius. Okay, dear at here. The lower the specific heat capacity, we warm up or we cool down fast or slow, dear? What do you think? Fast or slow? Copper block, copper block, heat up fast or slow? Teresa, it requires less energy to heat up, yes. Crystal, fast, yes. Zihua, fast, yes, correct. Angeline, fast. So Serene, fast. Okay, dear, yes. If your C value is low, you will heat up fast, okay? Quickly. Okay, if you want to cool down, actually it's the same idea. You need to release 390 joule of energy. If you want to heat up, you absorb the heat. You want to cool down, you release the heat. So no matter release or absorb, the amount of heat energy is small amount, so you can be heat up very fast, cool down very fast. Okay, for water, I need you observe your daily life. So you boil the water in the kettle, maybe 5 kg. I don't know how many ml, how many kg of water. The kettle, you boil it. Normally, if you want to boil it, roughly we need to take like 15 minutes. Okay, then after that it boil, you let it cool down. After 3 hours, you come and touch the water. You will find that the water still warm. Because water, why it take 15 minutes so long the time to heat up and boil, is because water specific heat capacity is high. In order to increase 1 degree Celsius, it need to absorb 4,200 joule of heat. So when we want it to cool down, same thing. I want to decrease 1 degree Celsius. I need to release 4,200 joule of the heat. So for this specific capacity high, it will warm up and cool down slowly as it takes more energy to change. Then just now lower specific capacity, it takes less energy to change. Okay, dear. If okay, we goes to your page number 2. Now it's theory and understand what is specific heat capacity tell us. Okay, how we do calculation. Specific heat capacity, just now I got told you what the unit is joule per kg per degree Celsius. So joule, that is energy E. Then divided by kg, 1 kg. So our physical quantity is mass M. And then degree Celsius, this is the temperature unit, okay? Temperature. I don't want you to memorize in this way. So we will rearrange. Number 3, we will rearrange. Okay, here unit for specific capacity is joule per kg per degree Celsius. If very seldom, you argue with me, teacher, can I in the Kelvin unit in Kelvin? Yes. But most of the time, IG doesn't asking you in Kelvin, okay? Okay, amount of heat absorbed or released, amount of energy, heat here, energy. Okay, I want to rearrange. So we will get E equals to MC, change in temperature. The triangle meanings changing. Triangle at here meanings changing, change of. Okay, this one is change of temperature. Okay, here I want to mark down this part. Change in temperature, we were using a larger temperature minus a smaller temperature to find the changes of temperature. Use larger value minus smaller value. If right now we are 40 degrees Celsius, I let it cool down to 30 degrees Celsius. So I should using 40 minus 30. Cool down or heat up doesn't matter. Just using higher temperature minus smaller temperature. Okay, that's all. Okay, so this part is energy. Energy. But the problem is sometimes they don't tell you energy directly. They want you to count the energy. Okay, previously we already learned about work done, energy, power, right? So what is the energy? Yes, Crystal, correct. Okay. So Zihua correct. What is the energy? E equals to how you relate with the power. Okay, so at here E equals to PT. Do you still remember? I told you Chinese. PT. Okay, you can using this to help you to memorize. PT. Running nose. So at here, this formula is not a new formula. We did learning about this. Okay. Okay, here PT, E equals to PT equals to MC change in temperature. These two formula is important for this lesson is important. All calculation will be based on these two. Okay, dear, at here, I want to emphasize, okay, energy unit is in joule, right? Energy is in unit joule. Therefore, MC change in temperature, every single physical quantity must be in SI unit also. Therefore, your mass should be in kg. This one no need because later on the specific heat capacity, it will be specific capacity will be joule per kg per degree Celsius. So degree Celsius and degree Celsius can be cancelled each other. Now I want to emphasize is the mass must be in kg mass. Okay, must be in kg. And then energy in joule, what, right? So your power should be in SI unit, which is the watt. And your time should be in SI unit, which is in second. This is the things that I want to emphasize. Okay, most of the time the question they give you in minutes, so you have to do conversion to the second. Okay, if no question, then we are going to try our past year question right now. Okay, I move. This is 2020 question, past year question. Specific heat capacity of solid P is greater than solid Q. What does this statement mean? Okay, can you guys read? And A, B, C, D, write your answer to the chat box. Angeline, yes. Teresa, no. C value is higher for P. Okay, that means that this value is higher value. So P value is higher. Crystal, no. Zihua, yes. Teresa, yes. Okay, dear, here, if your specific heat capacity is high, what does it mean? It need to absorb a lot of energy. It need to absorb more energy, right? Okay, more energy is needed to absorb. So at here, another things that we can know that it will heat up slow. And then it cool down slow also. Uh, at here, I want to emphasize for the answer B and D. Keyword at here, melt. Melt. This one confirm wrong. Why? Melt means that change the phase. But from here, we only changing temperature. We didn't change the phase. Change phase is something like from solid to liquid, liquid to gas, gas to liquid, liquid to solid. That is changing of phase. But at here, specific heat capacity is doesn't change the phase. Water still water. Okay, gas still gas, solid still solid. So at here, amount of energy we needed for the solid P is we need more because specific heat capacity C is high, like water 4,200. So we need to absorb a lot of energy. Okay, so any question? No question. We go to your next page, page number 3. Is it okay? Let's go to page number 3. You got one more chance. Okay, one more chance. Try. A 1 kg block of aluminium require more thermal energy to raise its temperature by 1 degree Celsius compared to 1 kg block of copper. So what is your answer? Zihua, yes. Angeline, no. No, this is 2019 past year question. Based on this sentence is the explanation. Teresa, yes. Crystal, yes. Serene, Xuan, Bora, correct. Bora, correct. Zihua, Zihua, why? Okay, dear at here, answer 1 kg need more thermal energy. Here, 1 kg, 1 degree Celsius amount of energy. This question must be related with specific heat capacity. So the only answer will be here. Okay, it want the statement related with specific heat capacity. Need more energy, that means your specific heat capacity is higher. So answer should be C. Okay, answer will be C. Any question? No question, we goes to question number 3. Can you try do calculation? By how much does the temperature of the block increase? Okay, how much does the temperature of the block increase? Do it right now. What is your answer? Always remember write formula, substitution, final answer with unit. MCQ we also practice. Right now we practice. Angeline, yes, correct. Emily, yes, correct. Zihua, Zihua, what is your answer? Crystal, Bora, try. What is the answer? How much the temperature increase? Okay, Zihua, correct. So this one is C. We label C. 2 kg. So this one is M. The internal energy is actually in terms of heat lah, okay? So this one increased by, so this is the energy we have. So E equals to MC change in temperature, okay? Sometimes they don't drawing the triangle, doesn't matter. I draw the triangle is because I want to emphasize this is the changes of temperature lah, okay? So at here 13500, the mass is in 2 kg, specific capacity is 900, temperature change. If you do everything correct, mathematics, press your calculator, everything correct, your answer should be C. Correct, Teresa. C. 7.5 degrees Celsius. C. Okay? Okay, like boys and girls, we go to question number 4. Okay, we go to question number 4. Can you try before I discuss? Question number 4. We got the aluminum block, mass is 200 grams, specific capacity is 900. How much energy is needed to raise the temperature of the block from 20 degrees Celsius heat to 110? Angeline, correct? Any others? What is your answer? Zihua, correct. Boys and girls, if you get the answer, you type in the chat box. So I know that actually most of you actually finish. So we got enough time. Crystal, correct. Hui Tong. Yes, Hui Tong, correct, dear. Daniel. Hey, we got new friend Daniel. Daniel, yes. Zihua. Okay. Teresa, correct. Serene, correct. Okay, dear, very good. So at here, energy is equals to MC change in temperature. C change in temperature. So this one is energy we want to count. Then this one, the mass is 0.2, dear, this part. 0.2. Then C is 900. Then this one change in temperature. You using the higher minus the smaller 110 minus 20. Okay, your answer at here, everything correct. 162,000 joule. Okay, you see why I need to change to kg. Because this part is in kg, here is in joule per kg per degree Celsius. This one is degree Celsius. So can you see that kg and kg at the end can cancel? If you didn't convert in kg, then it must be wrong because you are different unit already. One is in gram, one is in kg. Okay? Then degree Celsius and degree Celsius can cancel out. What is the leftover unit? The leftover unit is in joule. Therefore, energy in joule. Okay, so please remember convert the mass into kg. Answer is C. Okay, we goes to question number 5. Turn to your page number 4. Okay, can you try? Okay. Zihua, do not spam the message. Zihua. 13 new message. Okay, like dear, number 5. Zihua, no wrong answer. Hey, wait. Wrong answer, yes. Angeline, yes. Angeline, correct. Teresa, no. Teresa, no. Try final temperature. It will absorb 7,300. This is E. Mass is in 2 kg. So initial temperature. Then this one is specific heat capacity C. What is your final temperature? Okay. Hui Tong, correct. Okay, dear. So E equals to MC change in temperature. Okay. Well, I don't have my, oh yeah, I have my calculator. Wait. Okay, so the energy is 7,300. The mass is 2. This one 913. Change in temperature. Change in temperature at here it should be, let me count. Okay, so at here the answer should be 4 degrees Celsius changes. So initial 20 degrees Celsius. Then after that you increase 4 degrees Celsius. What is your final temperature? Your final temperature should be 24. Okay, so at here, your final should be your initial. Then we increase 4 degrees Celsius. Okay, so this one is change in temperature. So 20 degrees Celsius plus 4 degrees Celsius, we get 24 degrees Celsius. Okay, this is the answer. Final temperature, because here, let me have a look. Okay, keyword here, will absorb. When absorb, what does it mean? Final temperature will be greater than initial temperature. Final temperature higher than initial. So your final should be your initial plus the change in temperature will be your final. Okay? Okay, question number 6. We go to question number 6. Try. Angeline, yes. Zihua, yes, Zihua. Zihua say, why all is C? Yeah, I don't know why, but it's C. How many C are they? Okay, dear, count. What is the temperature of water after it has been heated? So at here, energy is equals to MC, change in temperature. Actually, same working step as just now the previous question. You see, similar idea. So when we do more past year question, actually we can understand how the question in IG they want to test us, okay? How the concept, what is the concept? So this one is 2021, this is 2016. Okay? Idea is the same. So at here, increase by 21. So this one, 21. Don't forget about the kilo, dear. Don't forget about the kilo. So it should be 21,000 equals to the mass 0.5. C is 4,200. Change in temperature. Okay, change in temperature. So we do calculation for this part. 21,000 divided by 0.5 divided by 4,200. So 10 degrees Celsius. Okay, here again, heated. Heated, that means that final temperature should be higher. So initial temperature, final temperature will be initial plus the changes. So we get 13 degrees Celsius for final. Answer should be C. Crystal, C. Yes, Crystal. Okay, boys and girls, can you try with question number 7? Copper container of mass 0.20 kg. So the container have the 0.1 kg of water. Specific heat capacity for the copper is 385. Water is 4,200. How much energy in joule is needed to raise the temperature of copper container and water by 10 degrees Celsius? Hmm. Zihua, yes. Angeline, yes. Okay, dear. Raise the temperature by 10 degrees Celsius. By, not to, by. So that means that changing temperature is 10 degrees Celsius. Okay? So sometimes they will trick you also. They say that temperature increase by 10 degrees Celsius. So your meanings that your final temperature actually is initial plus the 10. Okay, initial plus the 10. So at here, this one, your answer should be boy. Okay, copper and the water, they're having different specific heat capacity. That means that the amount needed is different. So you cannot plus together, straightly plus them together, cannot. We have to separate and count. So for this one, the mass of copper 0.2 mc, 385, then change in temperature is 10 plus the water 0.1 mc, change in temperature. Answer should be B. This is the way how you do calculation. Okay, we go to page number 5. Question number 8. Actually, it's last year I come out this question in the my assessment, school assessment, term 2 assessment. But a lot of my students, like 70% of them cannot get the correct answer for question number 8. Now, I want you guys try. Okay, think before you answer. Question number 8 is a very good question. This is 2020. I want you to think what is the correct answer. 70 to 80 of the students, 80% of the students, they cannot get the correct answer. So now it's your turn. Okay, who is that? I have to leave first. Wei Tong, is it? No. Angeline. Wow, Angeline, good eh? Yes. Angeline, correct. Today I let my this year 10 students do this question, but none of them able to answer. So only Angeline answer me. Any others? Zihua, no. Is it this is your answer? No. Hui Tong, eh? Try. Shu En, Hui Tong, Crystal, Shireen, no. No. Hmm. Bora, Emily, Daniel. This is a very good question. I like this question. Today, I just teach my students with this question, but none of them correct. Hui Tong, no. Okay, let me explain. Specific heat capacity, so we got two parts, okay? The aluminum and iron actually is the metal, okay? It's the metal. This is metal. So this part is liquid, okay? Then 1 kg of metal put inside the 5 kg of each liquid. The starting temperature for the metal starting is 60 degrees Celsius. Temperature for the liquid is 10 degrees Celsius. Okay, when we put the metal into the liquid, the metal will lose energy. Do you agree? The temperature for this 60 degrees Celsius, it should be decreased. Okay, then sorry, no, still no. Okay, here, then we will lose the energy. This one metal will lose energy. It will lose energy, thermal energy, okay? It will lose heat. Okay, lose heat lah. We say lose heat. Okay, this one will gain heat. Okay, now which example has the highest temperature? Now I want to ask you, I want higher temperature for the metal. I want it cool down fast or cool down slow. Ask yourself. I want higher temperature. I want cool down fast or slow. So that at the end is higher temperature. So I want cool down slow. Am I right? I want cool down slow. Okay, then ask yourself, C higher or lower, which one will cool down slow? That is the thing. I want cool down slow so that higher temperature, it will be a higher temperature after certain period of time, okay? I want cool down slow so that higher temperature. Then cool down slow is high C or small c? Answer me. Crystal, no. Crystal, for the metal part, correct. For the liquid part is wrong. Okay, so dear, just now we did mention what, right? C is higher, so it will heat up slow, and also it will cool down slow. Agree? In order to, at the end, we still get a higher temperature, I need to make sure the metal which is cool down, it will cool down. I want it cool down slow. So your specific heat capacity, you should choose the higher one. Okay, then how about the liquid? Liquid is heat up, okay? Liquid is heat up. It will heat up. Okay, when we heat it up, I want to get a higher temperature. Final temperature is higher. So ask yourself, you want heat up fast or heat up slow? Heat up fast or heat up slow? So at here, I want it heat up fast so that at the end, I can get a higher temperature. Am I right? Then ask yourself again. Heat up fast, specific heat capacity for the liquid, it should be high or low. It should be high or low. So it should be low. So only 2400 joule is needed. It already can heat up 1 degree Celsius. Am I right, dear? Digest one more time. Okay, maybe it's here like this. Okay, metal is 60 degrees Celsius higher temperature. So it will cool down when it mix or touching with the liquid. Okay, put inside the liquid. Then for the liquid 10 degrees Celsius, it will heat up. Okay, in order to get a higher temperature for the metal, of course, I want this metal cool down slow, because at here aluminum and iron actually they are cooling down when they are touched with the liquid. Okay, when they put inside the liquid, it will cool down. So we want cool down slow, so that at the end it's still high temperature. So how to make it cool down slow? We choose a higher C, because every 900 joule you release, you only decrease 1 degree Celsius. If you choose iron, 450 you decrease 1 degree Celsius, another 450 degree you already decrease 2 degrees Celsius. But for aluminium only decrease 1 degree Celsius. This one already 2 degrees Celsius. So that means iron will cool down faster. At the end, same period of time, aluminium still higher temperature. So we choose our answer as A. This is a very good question. I like this question. But do you able to get my idea there? If you get my idea at the reaction day, you give me some reaction so that I understand you already get the point. Hui Tong, okay? Only Hui Tong get this idea? Zihua cannot. Then how about others? Bora? Shuan, Emily, Crystal, Serene. If cannot, then you let me know which part you cannot. I need time to think more. Emily, okay. Okay. Yeah, this question need to think, need to digest. Bora, is it okay, Bora? And then Serene. Zihua, enough. Okay, so here, higher temperature. We want higher temperature. So we want cool down slow. C higher. We choose a higher C. Bora. Okay, Bora, okay. Crystal is okay. You mark it down. Then after that, you digest. Okay, you digest. Because higher temperature, we cool down. Then we want higher temperature, so we want cool down slow. Okay, next, number 9. Can you guys try? This one is involved with, if not mistaken, involved with some energy change. Yes. Temperature of water at the bottom of water flow is greater than the temperature of the water at the top. The gravitational potential energy of the water at the top is transferred to the thermal energy. Oh, this is a very important sentence. That means that GPE we convert to the energy, thermal energy. Specific heat capacity is 4,200. What is the temperature difference for the waterfall of height 21 meter? Okay, try. Can you try? Angeline, no, but almost there. Angeline, yes. Alice, is it? So GPE, we are convert it to the energy, thermal energy. GPE formula mgh equals to the energy involved with specific capacity must be E equals to mc change in temperature. If they didn't provide you energy, sometimes they give you power, then it will be PT equals to mc change in temperature. Okay, So at here, MC, change in temperature. Teacher, I cannot solve because the question doesn't provide me the mass. Actually, you can solve, dear. Because the mass of the water falling, okay, and then converted to the thermal, the mass of the water is the same. So the left hand side mass and right hand side mass can cancel out. You can cancel it. Crystal correct. So at here, G is 9.8. H is the height 21 meter. Then C is 4,200. What is the temperature difference? So your temperature difference, if you do everything correct, your answer should be B. Okay? So for this question that tests on you, do you know energy transfer? Do you know that the mass actually is the same? Okay? If they want to make this question more tricky, they can say that the GPE, the amount of GPE maybe like 20% of them is efficiency, 20% efficiency. So you need to calculate the useful energy, output energy first. Then only that energy is for the thermal energy. If they want to make it more tricky, the question. But this question still okay is because they're just telling you GPE equals to energy, thermal energy. So nothing energy loss. Okay, nothing energy loss. We assume perfect 100% efficiency. Okay. So we goes to your page number 6. Like there, we goes to page number 6. Okay, can you try? Water has a specific capacity. Oh, this question easy, okay? Boiling point is 100 degrees Celsius. A mass of 0.3 kg of water at its boiling point is poured into a copper container, which is initially at 11 degrees Celsius. Okay. After a few seconds, the temperature of the container and the water become 95. Calculate the energy transfer from the water. Now I'm talking about water only. Okay, water pour into the copper. Copper only 11 degrees Celsius. So for water, of course, it will decrease temperature. Of course, it will decrease temperature. Then for the copper, it will gain energy, higher temperature. Then after a few seconds, both of them achieve 95 degrees Celsius. Ask you, how much energy transfer from the water to the container? Any of you? What is your answer? Kristen, no. Kristen, no. Zihua, yes, but unit is wrong. So you're also only able to score 1 mark. Unit wrong is wrong, dear. Energy. Angeline, did you get the answer? Zihua correct right now. Energy, okay, lose by transfer from the water. So we're talking about the water. The water mass is 0.3. Specific capacity for water 4,200. Change in temperature. Ask yourself about water only. Water starting is 100 degrees Celsius. So this is initial. Okay, final temperature of water is 11 or 95. Ask yourself. Bora correct. Bora correct. Good job. Okay, 95 is final. So I told you using larger temperature minus smaller temperature. So we should using 100 minus 95. So your answer for this question should be 6,300 joule. This is the energy transfer from the water, and this will be the energy gained by the container. Okay, it will be the energy gained by the container. They want to trick you, they can say that, can you calculate the energy gained by the container? Well, you will feel panic. What? Container? I don't have the mass, I don't have the C for the container. But if in a perfect case, how much I lose is how much you gain. Okay? The energy transfer from the water actually is equal to energy gained by the container. So if they want to trick you, they can change this sentence. Okay, calculate the energy gained by the container. But the answer actually is the same. Working step is the same. Okay, because we understand energy lost by the water is equals to energy gained by the container. Okay, so this question, if no question, we go to question 11. Okay, we practice question 11. So this one is slightly involved with the work done energy power. Okay, can you try? Solar panel receive energy from the sun at a rate 5.0 kilowatt. So this one is your input. Solar panel receive. Okay, the thermal energy is transferred from the solar panel. So solar panel will produce thermal energy. Okay, but only 20% efficiency. Input is 5,000 watt, but only 20% is the useful thermal energy. So you have to count out. So after the 20%, how many left? This energy is goes to the heat the water, is it? Yeah. Cold water of mass 15 kg enter the solar panel every hour. So this is the time. Sometimes not in the digit, but in words time every hour. So time is 1 hour. Specific capacity for water is 4,200. Can you calculate the temperature increase of the water? Okay. Once you settle with question 11, I answer Shuan question. Okay, dear, here is they didn't say have any energy loss. So because we pour the water, let me have a look into the container. Okay, so the container, the energy will be loose, okay, from the water, loose by the water, from water. This amount of energy will be gained by the container. Let's say I lose 10 ringgit and you get 10 ringgit. There is nothing lost in between. Okay, so at here, water is at higher temperature, is 100 degrees Celsius. So temperature will decrease. And then this one, 11 degrees Celsius, temperature will increase. One is lose energy, one is gain energy. Is it okay? One is lose energy, one is gain energy. So if this question they say energy transfer from water, they also can say that can you calculate energy gained by the container? Their answer should be the same, 6,300 joule. So Shuan, is it okay? Because two touching contact have thermal contact. Okay, have thermal contact. So the water with higher temperature, it will lose energy. Then lower temperature, it will gain energy. When there is no energy loss to the surrounding, we assume everything perfect. So the loose energy from the water will be equals to the energy gained by the container. So Shuan, is it okay? Okay, okay. Then Angeline. Angeline, correct. Very good. Okay, dear, here, efficiency formula. I told you efficiency is like N, but slightly longer with the tail. Slightly longer with the tail. Then after that equals to this is output, useful output divided by input times 100%. I got 20% efficiency. Then solar panel receive meaning that this one is input lah. Okay, so this one is 5,000. Do not forget K is 1,000. K is 1,000. So output times 100%. Okay, 5,000, 20% of 5,000. Your output actually, the useful one, only 1,000 watt. If like this, you already score the mark. 4 mark at here, you're already able to score the mark. Okay, 1,000 is useful, although we get 5,000, but only 1,000 is useful. The rest 4,000 is wasted to the surrounding. Okay, then after that, we need to find the temperature, the energy, right? Energy is equals to MC, change in temperature. Every time when you saw specific heat capacity, we only got two formula only. E equals to MC data, or E equals to PT equals to MC, change in temperature. Only these two formula, no others formula when they mention about specific heat capacity. Okay, what is the power? Power, just now you did calculation is 1,000. What is the time? Can you see that? They say every 1 hour, mass is 15 kg. So this 15 kg actually is for the 1 hour. So at here, 1 hour, please remember I told you, energy is in joule. So power in watt, time must be in second. Okay, time must be in second. 1 times 60 times 60. 1 hour, 60 minutes times 60 seconds equals to the mass 15 kg. C is 4200. Temperature increase 57 degrees Celsius. Here is the point. Okay, digest this question. Digest this question. So this question already involved with the knowledge that we learned previous chapter about the world energy power efficiency. Okay, receive is input 5,000. Then useful only 20% of it. 0.2 times 5,000, you get 1,000. This 1,000 used to heat up the water. Okay, then at here every hour, it doesn't write in digit t equals to 1 hour, no, but every hour we need to understand time is talking about 1 hour. 1 hour, the mass is 15 kg. So remember, you have to do conversion to second for this part. Why? Because energy in joule is SI unit, so your time should be in SI unit also. So your answer is 57 degrees Celsius. Okay, is that clear for this part? Give me reaction. If got question, then you ask. Okay, good job. Okay, good job. There we go to the page number 7. Teacher, why we need to learn about specific heat capacity? Okay, it's very useful in our life application. So when you are a designer, you have to think how you are going to design the pot, cooking pot. So you always ask yourself, hey, the aluminium body here, this part. You want to have a cooking pot, design a cooking pot. You want to heat it up faster. Of course, you want to heat it up faster. So ask yourself, you want heat up faster? Specific heat capacity should be low or high? Answer me. You want heat up faster, so your specific heat capacity should be high or low. That is a very important concept. Serene, correct? Okay. So this one answer should be low. Low C. So just now we say C is for aluminium. Actually, you no need to memorize, but I did a lot of questions. That's why I memorized. 900 joule per kg per degree Celsius. It only need 900 joule. It already able to start to increase the temperature. So we want low specific heat capacity, okay, the material. So low density is because I don't want too heavy, the pot too heavy. Okay, then copper base. The base at here we choose copper. Okay, why we choose copper? Do you still remember page number 1? The copper, You see here. Aluminium is 900 joule per kg per degree Celsius, but copper only need 390. We can say that 400 lah. Can you see that? Half of it, less than half of it, okay, of the aluminium. What does it mean? Means that copper even much more faster heat up than the aluminium. So at here, the base at here, we want to choose a low specific heat capacity. Okay, this one C for aluminium is 900. No need to memorize, but we just for our own understanding. So this one for the copper is 390 joule per kg per degree Celsius. Okay, copper is very good. Am I right? It can be heat up very, very fast. But teacher, why we don't using copper for whole part? Since I want to cook, what I want to heat up faster, what? Why not the body I also using copper? Any of you know the idea? Why? Why? Any of you can answer me? Why base need to using copper? Then body I don't want using copper. Why I choose aluminium? There is reason. You know why? The copper is very good, heat up very fast, but the problem is copper is very expensive. Copper is expensive. Aluminium is cheap. Therefore, in order to reduce the cost, so we use this part to use the copper material. Then the body we choose aluminium. Although slightly slower, not good that like the copper, but it's still fine. Okay, it's still fine. So at here next, how about the handle part? Your hand will be put at here and hold it. So you ask yourself, you want the handle heat up fast or actually heat up slow? Okay, heat up slow. So we want it will not become too hot when heat is absorbed. We want heat up slow. So what kinds of specific heat capacity you want? Yes, surely yes. Just why yes. We want high specific heat capacity. We want high. And then poor conductor of heat. Okay, here, dear, from this ABC, I can make a conclusion. Can you see that? Metal is a material that heat up fast. Alright. Metal C value is low. Okay, insulator, heat up slow. It's a poor conductor, okay? Metal is a conductor, okay? Conductor. So this one I can say is insulator, then heat up slow. If heat up slow, the value is high. For example, wood, rubber, water, all this belongs to high. Then metal, iron, aluminium, they are good conductor of heat. Their C value is low. Okay, so for this part, is it okay? We go to the next part. Cooling system for the car engine. How we choose a cooling agent. Okay, at here, we want to cool down our car engine. Actually, we will always open the front part. Okay, we will add the water in. Next time you ask your parents to show you lah. Okay, we'll add water in. Water will be very important as the cooling agent in our car engine. It's because water has a high specific heat capacity. The water specific heat capacity is 4,200 joule per kg per degree Celsius. What does it mean? Why we need high specific heat capacity for water? Okay, water will be inside here around the machine. So the machine running, okay, our car running, so it will release a lot of heat. Okay, release a lot of heat. How to let the heat go up? We need the water helping us to cool down the machine by absorb the heat. So the water will help us to absorb the heat from the machine, okay? Then it will bring it out from the car, okay, or from the machine. So at here, water can absorb a large amount of energy without heat up. Water can absorb a lot, then temperature only increase a little bit only. So water is a very good in helping us absorb the heat from the machine. And water itself also does not increase temperature easily. So we're using water as the cooling agent. Okay, high specific heat capacity. It can absorb 4,200 joule of energy. Okay, only increase 1 degree Celsius. Then continue absorb another 4,200 joule of energy. Then we increase another 1 degree Celsius. Okay, get it? So if okay, then can we go to page number 8? Yes or no? We finish page number 8, then we only dismiss. Let's go here. Okay, dear. If you are girls, I will tell you that, dear all, when that thing, okay, daytime is good or nighttime is good. So now I'm going to teach you. As a girl, I will tell you that daytime is better, dear. Daytime is better. Why? Okay, look at me. Why? So you listen to me. Land and sea. Think. Land and sea. Which one will heat up faster during the daytime? You imagine and think. Water, sea is sea water lah. Water and land, which one will heat up faster? Okay, so at here my answer is land will heat up faster. If land heat up faster, meaning that the C value for the land actually is lower. Am I right? Okay, heat up faster, that means that here the air particle above the land, they are warm air. Warm air. Warm air will go up. Cold air will go down. This one is convections. Year 9, we did learn about this. Okay, warm will go up. Why? Because density. Okay, density. When warm, the volume will increase. Density will decrease. It will become less dense. Less dense for warm air. Less dense will go up. Then cold air will be denser. Cold air denser, it will sink. Okay, then at here, warm air go up, cold air will sink, something like this. So can you see how the wind blow? The wind will blow from sea towards to the land. So if you are sitting at here, this is your head. Can you see? This is your hair. So your hair blowing, like you having the effect of having a fan. Then you do the advertisements for your hair shampoo. Your hair will blow backwards. Okay, like this. Very nice. Okay. So what happen if we goes at night time? Okay, goes at night time. So just now I told you what the land will heat up faster, so it will cool down faster. Also heat up fast, then cool down fast, right? So this C value is low. C for the land is low. It will cool down faster. So at night time, the sea still warm. The sea, the air particle above the sea is warm air. Warm air go up, you see, warm air go up, cold air will go down. So at the end, how the wind blow from the land towards to the sea. So you imagine you are sitting at here, this is your hair. You see, this is your hair. How the air blow from back to the front. So you will look like a ghost. Okay, cannot. So girl, we want pretty, so we cannot. Nighttime is not a good idea. So we want daytime. Then the wind will blow from the sea towards us. Okay, that is nice. Okay, this one actually is related with specific heat capacity lah. Okay, so we fill in the blank. Energy from the sun is absorbed by the sea and the land. Land has a lower specific heat capacity, so temperature will be heat up faster. So land will heat up faster. Land is warmer. Okay, the air above the land is warmer. It will be heat up and it will rise. Why rise? Is because less dense. Why less dense? Just now I told you density is mass divided by volume. Volume higher volume. Okay, the cold air from sea, so the air will blow from sea towards the land. Okay, this is called sea breeze. Okay, so at night time, heat will lose. Then because the land has a low specific capacity, it will cool off faster. Just now heat up faster, now cool off faster. Land right now cooler. Just now warmer, now cool down faster, so it cooler. Okay, then above the sea, that is warm air. Warm air go up, cool air from the land will move towards to the sea. So this is called land bridge. Okay, So the next is the experiment part and do calculation for the specific capacity for the aluminium and water. Teacher, how you know that water is 4,200? Teacher, how you know that aluminium is 900? Actually, all these value they did calculate using the experiment. Okay, that one we will continue by next week. So for today lesson, any question? If no question, then that's all for our lesson today.